Good morning. If you're watching this, it's because I'm at the Kasuth County Courthouse this morning where I got called to serve on jury duty. I recorded this Friday when we had no school, and hopefully it'll give you an idea of where we're going next in advanced algebra. Today we're going to learn just a little bit more about how to do some math with matrices. I will be showing you some more stuff that you can work with on graphing calculators. However, the other day, when we didn't have quite enough for everybody in fourth period, Skylar was showing me that he had downloaded an app called Calculate 84, and it does work pretty much the same way as graphing calculators do in real life, and it happens to be available for free for both iPhone and Android. And if you do want something on your phone, that's probably the best app that you can download. Remember earlier in this chapter, we learned some basic things about matrices. We learned that rows always read across, columns always read up and down. In this matrix, for instance, you have 2 rows and 3 columns, so it's a 2 by 3 matrix. We also learned how you could add or subtract matrices by hand, and all you did was you looked at the numbers that were in the same place and you added them up. So like in the top one, 3 plus 4 gives you 7. You also have 8 plus 0, 4 plus 1, 6 plus -9, and your answer is just a 2 by 2 matrix like you started with. The same kind of rule works for subtraction. And finally, we learned what we called scalar multiplication. That was a lot like the distributive property. You just took a number and you multiplied everything in the matrix by that number. The next obvious question is what happens when you multiply matrices? I've got a couple of 2 by 2 matrices here, and you might think for a minute, what would be the answer if you multiplied them? If I was at school today, I'd probably ask people what they thought the answer was, and almost certainly most people would tell me that it's 5, 12, 21, and 28. They would just think, okay, we're just going to multiply all the numbers that are in the same places like we added. But that's not quite how it works. Here are some screenshots that show you how the multiplication on the graphing calculator is working. You can see I put 1, 2, 3, 4 in as matrix A, 5, 6, 7, 8 in as matrix B. And when you do A times B, the answer isn't probably what you would have expected. You end up getting 19, 22, 43, 50. And here's a couple other multiplication problems that I want you to look at for a minute and see if you can figure out what's going on. You can see at the top we have 1, 2, 3, 4 times 2, 0, 1, 2, and the answer ends up being 4, 4, 10, 8. In the middle, you can see 2, 0, 1, 2 times 1, 2, 3, 4. So it's basically the same thing backwards. But you don't get the same answer. You get 2, 4, 7, 10. And finally, at the bottom, you'll see two matrices that aren't even the same size. One is a 2-row, 3-column matrix. The other's 3 rows and 2 columns. And when they did the multiplication, they got a 2 by 2 matrix with some comparatively large numbers. I'm going to pause for just a second and see if you can think what might be going on here. Here's how a book would explain what's going on. I'm going to break it down in a minute, but the key thing is it has to do with rows of the first matrix and columns of the second. So for instance, if I look at the top row of the first matrix, 1, 2, 3, and I look at the first column of the second matrix, 7, 9, 11, what I do is I multiply the first number times the first number, second number times the second number, and third times third. I take 1 times 7 is 7, 2 times 9 is 18, and 3 times 11 is 33. And I add up 7 plus 18 plus 33 to get the final answer, and that number is 58. Pretty much the same things going on to get the other numbers in the answer. The 64 comes by taking the top row of the first matrix times the second column of the second matrix. They did 1 times 8, 2 times 10, 3 times 12, and added everything up. And then they got the other two numbers by going down to the bottom row of the first matrix. You take them times each column of the second matrix. For instance, the very last number was 4 times 8, 5 times 10, 6 times 12. Add up all of those numbers and you get 154. You remember I told you that you could use graphing calculators to save time when you're working with matrices, and multiplication is the big thing where that's a time saver. If I were here today, I'd have you guys take a minute and enter matrix A and matrix B, and then actually do A times B. You can see I've done that here, and you do indeed get the exact same answer as when I talked about it by hand: 58, 64, 139, 154. When you're multiplying matrices, I generally will expect you to just use your graphing calculator. However, there are a couple of things you do need to know. The most important of those is that the answer when you're multiplying matrices always has the number of rows from the first matrix and the number of columns from the second. So what these weird shapes are showing you is that a 4 by 3 matrix times a 3 by 2 matrix would end up having 4 rows and 2 columns. You get the rows from the first one, the columns from the second one, when you find the dimensions of the answer. So here's a quick question. It says if you had a 5 by 2 matrix and a 2 by 4 matrix, what would be the dimensions of the answer? And while I can't ask for volunteers to answer this virtually, hopefully you can figure out it's 5 by 4. Again, rows from the first, columns from the second. Here's another. Think about what the answer would have to be. And this time it's going to be a 3 by 2 matrix, 3 rows, 2 columns. So this question shows you the other thing that you need to know. Here I have a 3 by 2 matrix and another 3 by 2 matrix. And the question says, why can't you multiply these? What's the problem? Why would these go wrong? So the problem in this one is that the number of columns in the first matrix, 2 columns, doesn't equal the number of rows in the second one, 3 rows. In order to multiply, those numbers have to be the same. If you try to do a problem like this on a graphing calculator, you're going to get an error. It tells you dimension mismatch. And again, the big thing is those middle numbers. The columns of the first one and the rows of the second one don't match up, so you cannot multiply those matrices. In the example I have here, 1 by 4 and 4 by 4, because those 4's are in the middle are the same, then yes, you could multiply matrices with those dimensions. Again, the middle numbers have to match. So if I gave you a problem like this one, and I said, what is BA? You'd look at B and think, gee, that has 2 rows and 1 column. A is 2 by 2. That 1 column on B and 2 rows on A, those don't match up. And so you can't do that problem. It's impossible. The other thing you might be asked to do with multiplying matrices is to explain how you could multiply a couple of simple matrices by hand. Now, you could put these into a calculator and it'll give you an answer, but the question is, how would you do this by hand? The idea here is that you want to remember that you match up first with first, second with second, you multiply, and you add. So here, what you got to do is take 7 times -1 plus 3 times 4, again, first times first plus second times second. You add up -7 plus 12, and the answer is 5. Technically, what you have is a 1 by 1 matrix, one row, one column, with 5 in it. So again, you'll mostly be doing your multiplication on calculators, but what you want to know is, can you multiply two matrices or not? Again, those middle numbers have to be the same. What are the dimensions of the answer, which you get from the first and the last number, the rows of the first one, the columns of the second. And finally, what do you do to get individual numbers in the answer? So hopefully that tells you what you need to know to multiply matrices, and hopefully I'll be back next time to work with you in person.